Thanks for coming, everybody. Thanks for everyone for showing up. This is something that Daniel and I care a lot about. We've been working on these kinds of problems for large portions of our career, and we're happy to see some progress going forward. And so we have some ideas about it. We've been talking to the community about it, and this is what the talk is what we think, where we can go from here, basically. My name's Bret. I'm a software engineer at Bloomberg. I work in the developer experience department. I'm the lead of the build tools team. We focus on compilers, build systems, standard libraries, base, building your code support for the entire company.
My name is Ruoso. I work also in developer experience at Bloomberg, and I work in the code governance team. We essentially try to move the entire code base forward. My team also does a lot of static analysis and automated refactoring. Some people may remember that I gave a talk 2 years ago about Clang MetaTool. The joke is that I am the janitor. I go sweeping off the old code from people. I have been working with the build system and package management space for 20 years now, I think. Because of my involvement in Bloomberg, I've become more interested in solving the C++ space. So before we talk, I think there's a few things to clarify about this talk. The first is that we're talking about C++, but this is not only C++. C++ is a language that interoperates with any other language that you can think of. I think the talk before was about integration with JavaScript. And Python folks need to bind, and we need to call C, and we need to call Fortran. The punchline here is if you can't depend on libcurl, we failed, because it's a library that a lot of people use. And also that a lot of downstream environments need our help. I mentioned Python before. Embedding C++ in Python is kind of a pain, and the same for pretty much any other language. We need to be able to make choices. What does it mean? We're not going to be able to get everyone on the same page that everyone agrees packaging should work exactly like this. And we're not going to be able to say we have a packaging system that fulfills all possible use cases. That's not realistic. And so we will need a very flexible approach. And that flexible approach needs to essentially allow people to diverge. But as we diverge, we need to be able to still be on the same page of how we talk about that divergence. You can think of an analogy of you have the globe, that's a really complex thing, and it's really hard to reason about in 2 dimensions. And then you have different projections and different maps and coordinates. But those maps and coordinates allow us to talk about this, where we are in these different parts of the space, even though we are in divergent parts of the place. This talk is not about covering how package manager A or package manager B works. We're not here to pick winners. We like the healthy competition that exists today between build systems and package managers. And the main goal is that it should be easier for library maintainers to interact with all those different package managers. Should be easier to build systems interact with all the different package managers. And users should be able to just make choices on the merits of the implementations they choose without fearing that they're isolating themselves because of those choices. Yeah.
So why focus on packaging in the first place? There's a lot of things we can be thinking about, right? So why packaging, why now? First of all, adding dependencies is a real pain. And this has been covered in other talks, but in other articles, but it's one of the biggest pain points in our community, possibly the biggest. In fact, I don't care to actually rank the top ones, but it's absolutely top tier problem we should be working on. And that's the case we're making in this talk. For example, if you're new to the C++ ecosystem and you want to start depending on something and you maybe read some half-baked articles and something doesn't go the right way, you get an error message that is often very cryptic. You'll hear something about, what's a duplicate symbol? I don't know what that is. And why can't you find the header file? I can see it right here on my file system. Those kinds of problems are very indirect error messages. It's not saying, oh, you didn't depend on a package, or your thing was not vendored into your monorepo, or whatever that is. We're not describing the problems on the terms of how the user's thinking. We're describing them in terms of a tool that does not have complete information about what's going on, right? So let's say you did understand the error, though. Maybe you had someone sitting next to you that has been a veteran in the system, in the ecosystem, and they say, "Oh, you're just missing that dependency," and they say it in those terms. Well, how do you find the dependency? Is it even in your package manager? Do you have to go find it and pull it in? Is that your job? How does that work, right? And then you pull in that dependency. Does that pull in more dependencies? Do you have to do more of that work? When does it end, right? This is a big problem. And once you have all those things figured out, let's say you knew you had to pull in this set of 20 different dependencies to do the job you're actually trying to do, how do you actually build correctly against all that sort of thing? Right now, most of the time, like we just expect the end user to figure it out in their build system, add some magic flags here, add some magic flags there. We would not tolerate that kind of thing in our C++ code, but we tolerate that kind of thing in our C++ projects every day. We need to do better, right? This is Matthew Repaired. He has a lot of great content on this area. Other speakers have as well. This is him in ACCU, I think 2019, talking about header-only libraries. And from his perspective, the existence of a header-only library and the popularity of header-only libraries is a symptom. And in his talk, he makes the case that the reason people use header-only libraries is because they don't trust the rest of the ecosystem, and they don't trust other engineers to like the rest of the ecosystem well enough. Like we don't package because we don't think other people want to use our packages because we don't think the packaging ecosystem is good enough. So we're making the case in this talk that it's time that we made it good enough, right? We've talked about this before in other talks, right? Because we don't have a way to ship good code that is accessible to all of us, we instead try to standardize these things as, again, an end around to the fact that we can't package things, right? Too many problems are interesting in the standard library purely because we just don't know how to share it otherwise and share it portably otherwise. I think it's time we take another stab from a different direction and try to work on the tooling and the packaging instead. An example that's been brought up by many people is just the discourse around, do we need graphics in the standard library? That's an interesting problem set, has a lot of interesting things to talk about, but it's worth noting that we're not talking about why aren't you just using Project X, right? There's a general, not everyone feels this way, but a lot of people feel that like we should have overwhelming adoption preceding standardization. We should already understand the problem really well. In fact, maybe even have de facto standards with some significant warts before we figure out that, yeah, we should probably enhance C++ itself, the standard library itself, and clean that up. So it lowers the cost to use those features, right? We're not understanding problems well enough before we start shipping changes. We should see more competition. A lot of times when we're having these discussions about what goes in the standard library, we're not exactly talking about parallel implementations that exist in reality and people could actually try it if they wanted to. It's more about notional things that might maybe be implemented at some point. In fact, some standardization efforts kind of stall out because we don't have any implementations, partly because no one knows how, if you did have a good one, you could even ship it in the first place, right? And then committee-driven design leads to real-world pain points. Again, this might be a little opinionated, but I think a lot of people have this opinion, that these kinds of committees are better at ratifying things and maybe tweaking things than maybe developing them in the first place, right? And maybe some examples of things that have been hard to maintain and use to our satisfaction are things like IOStream and regex, which we're both in different ways backing off from as a community. Even though they're still standard, you can still use them, they're not going to change. But we have been like iterating on those problems, right? As an anecdote, C++ parallel algorithms, for example, for packaging problems, a lot of people don't know that to use C++ parallel algorithms on the GCC toolchain for certain versions of GCC, well, all of them up to now, right? You have to depend on a non-standard library. Who knew this? Who knew that? Like coming into this, like about half of us, and we're some of the experts in the industry, right? Who expects the people that start on their teams to understand that, right? So like these kinds of problems are the problems we need to work on. Here's Bryce in this conference last year online talking about this problem, right? And he's saying this was a talk, the point I just made was an hour and a half given by Bryce. You can go watch that. I could pick I could have screenshotted half of that conference talk and brought it up in this context because they all supports what I'm trying to say. Here's one that's talking about the stability thesis and just, we should know what we're doing before we standardize it. Like, we should be sure it's not going to change. We shouldn't be regretful after we standardize it. We should have a really good understanding of it, right? And then binary compatibility is hard. As hard as it is to figure out how to, my earlier slides about finding your dependencies, your transitive dependencies, pulling them all in, understanding how to package them, understanding what your build system needs to do in order to build against it. As hard as all that is, it's even harder to get your binary compatibility flags correct. And partly because we just don't carry that metadata around, and we don't, like dependencies don't teach each other how they will affect your build commands and your link commands. And this is, again, a problem we need to start working on. In particular, the one definition rule comes up in this space. There's a lot of presentations of it, but you can look for if-defs in header files, including header-only libraries, because they don't have many other ways to make choices. If it's Friday, use this structure. If it's Saturday, use that structure. If I'm on C++14, use this other thing. But again, if you're in a header, you have no control over how you're compiled, or you're not even declaring how you should be compiling against you. So one dependency in the dependency graph pulls in the version that uses the boost optional. This dependency in the dependency graph pulls in the standard optional, and there you go. You got a one definition rule problem, and if you're lucky, a compiler or a linker error. If you're unlucky, a production problem, right? Certain ABI choices actually happen at the ecosystem level, what we call the package management level, right? Like like I just pointed out, an example, if some code does one thing when you're using C++ version A, the same code does something else if you're using C++ version B. Headers are transitive. They're parsed in the context of the actual translation unit. So who wins? Well, everybody loses sometimes, right? So we need to work on this kind of thing. And again, linkers and compilers don't have enough to tell you. The error message you should have gotten is, you mixed your standard library versions. That doesn't work for this project. We don't get that error message. We get, again, something blows up in production perhaps. That's not acceptable, right? Yeah, go ahead.
Can you define what you mean by the package management level? Like, what is that, the current state of things?
Yeah, that's a fair question. The point is that when you're building in a context, sometimes the ecosystem itself needs to make a choice, like what C++ version you're using, what architecture you're using, which kind of floating point math you use. There's what kind of packing you do in your data structures. There's a lot of choices you make that are very subtle, but they do end up affecting how, when the generated code runs against a particular address, how that content of that address is interpreted. So if there's a disagreement about how tightly you pack data or what the alignment is, you might actually get data corruption because, component A thinks there is a piece of padding, component B thinks there isn't, and then you get, go ahead.
And is this determined at the compiler level at this point, or like?
It's determined
All of the above.
everywhere. There's nobody in particular is determining it. It is a bunch of things that cobble together when your build system decides what actual command to run.
In the end, it goes to the compiler.
And in the end, it's flags you pass to the compiler, yeah.
Okay.
And the linker, because that also matters. That's another problem, is when your headers don't match the things you're linking against.
Okay.
Yeah.
Thank you.
Yeah.
To remind you to repeat the question.
Yeah, I'm sorry. Yeah, I'll have to repeat the questions better. Hopefully, I think the audience would have got that from context, but there was just questions about what does package management mean, and how exactly it presents itself when push comes to shove, like at the end of the day, right? And part of the reason we're talking about it now, like why now? Well, modules, right? Everyone wants modules. Who thinks modules are ready, right? We're getting pretty close as far as some of the tool chain goes, some of the ecosystem goes. We're getting pretty close. The compilers are getting there. Maybe might have a couple of years maybe before we have the first, go ahead and try it out for real implementations on the major platforms. The build systems are not there yet, though. The packaging systems are definitely not there yet. Daniel and I have been talking about this with Study Group 15 and ISA, the tooling study group, about how possibly we can ship packages that contain modules. These are problems that, as we're getting into it, our opinion has been, like, we're going to have to actually dip our toe into the packaging space to really get modules to work. And that's kind of what this talk is about, right? And we barely had a working solution before. Let me get to that in a slide and I'll catch you We barely had a working solution before with textual inclusion, with headers. Like but we knew some things, like how to build a header, because you would just build it in however the source file wanted to build it, right? Because it's textually included. These are new problems. And the header, now the header is supposed to have a little more control, for example, of how it's getting parsed. Yeah, sorry. The module interface unit is going to have more control over how it's supposed to be parsed, and how does it communicate to the transitive declude, the transitive import, right, down the chain, that what those requirements are. These are problems we need to start thinking about. And again, let's not force choices in our ecosystem. We don't want, what happens if like a particular library decides to become modular in the new version, and some ecosystems support, some build systems, some packaging systems support C++ modules, some don't. Do we just fork that entire library? Is that acceptable? I don't think so, right? So how do we support that, right? How do we make sure everyone stays together in the same community, shipping the same code together? Here's a thread of us trying to figure out, and this is a thread, this is like a third of it at this point. It's been going on about like how exactly we can like describe how packaging and modules work together. So it's an ongoing area of discussion. If you want to join on SG15 and help figure these things out, that'd be helpful. But we're just, yeah, Jeff, sorry.
Do you, so obviously in C++ 23, the standard library will have modules
Right.
for the standard library. Do you not think that that will be an impetus to actually fixing this problem?
So the question was, given we're going to have a standard module and then a standard compat module, would that drive this kind of work? I think yeah, but I think that adds to the reasons to work on this. If that's what you're asking, like slightly, yeah.
The compiler vendors basically, to implement that feature, they have to eat their own dog food.
Right, so you're saying the compiler vendors have to figure out how to get it working for themselves and their test suites, et cetera, for this to work. I think that's a good point, and some of the problems will have to get solved that way, but a lot of the problems we're going to be describing in this talk extend far beyond what their purview would be anyway, so. Right. Yeah.
So one, and that's actually the subject of that thread, is that there is a very clear distinction between making it work for the trivial case and making it work for real. Gabby made a fantastic analogy, which is a lot of people like building sandcastles, and sandcastles are nice, but we actually need to build skyscrapers, and we can't build skyscrapers out of sandcastles.
So yeah, and again, like why are we doing packaging? Well, because there's a real cost if we don't, right? And they're not going to go away if we ignore it. It's going to continually get more expensive, not less expensive, to develop C++ or develop against C++. All you out there that want to move to other languages or want to write in higher level languages that have to call C++ because you don't have any choice but your libraries. This all affects all of you too. We do want to grow the standard and put more things in. We'll keep trying to put more things in the standard for the wrong reasons, not just because it's something that's ready to be standardized and that would add a lot of value on its own merits. Reusing libraries will get less ergonomic as time goes on. As much as we're frustrated, it'll get worse, right? It'll be possible to teach portably. I would love to see more content where people teach at conferences when they go to your workplaces and do C++ classes. Here's how you build C++. Here's how you package C++. But all teachers right now, and I don't blame them, don't generally offer those courses because they tend to be very narrow. Here's how you package C++ the way I do it. Here's how you build C++ with this build system that hopefully you're using the way I'm using it. And it's just not it doesn't scale because we're not even talking the same languages, right? Well, we're talking C++, but the build system is definitely not the same language. Yeah, there you go.
So one important question that can be asked is like, why are we particularly bad at this? Like, why is convergence so much harder in C++ than it is in the Rust ecosystem or the Python ecosystem or the JavaScript Node.js ecosystem? The reality is C++ being a very old and very widely used language, there's a lot of local solutions that work really well. And they are effective enough, even if they're divergent. And that's actually fine, right? What is a bit less fine is that larger C++ organizations have just accepted that as part of the cost of doing C++ stuff, you probably need to have a team that knows how to maintain a package repository, that knows how to build everything coherent, and knows how to prevent ODR violations when an application developer that just wants to write a system is trying to consume a bunch of dependencies, right? So we just accepted. Bloomberg has at least 2 teams working only on the package orchestration build system, because that's a requirement for doing C++ at scale. But smaller organizations cannot afford that, right? It's not fair. And the diversity, at the same time, the diversity in the build and package management ecosystem is actually actually necessary for that reason, because it allows smaller organizations to just figure out a solution that work on their particular use case. They don't have to worry about all the use cases that they don't care about. So they find a solution that works well for them, and it's fine. There's nothing wrong with that. And I don't think we want to discourage that in particular, right? I think there's an analogy here on like the init system on Unix, where we actually had like built some sort of interoperability where people doing like Debian package management and Red Hat package management, for a while at least, had a mechanism for them to converge on how to communicate how a service starts, right? So this is a similar thing. In a similar vein, every package management system or every package management ecosystem ends up with a lot of fixes for their local use case. Maybe they need to patch boost in a particular way to compile in the version of the compiler that they're using. Maybe they need to do some fix to prevent some specific ABI problem on the platform that they're using. And those fixes are not easy to upstream, because they can't really talk about how to push that change to the library owner. And a lot of times it's just not economical to do so, because it's easier to just add a patch file to my package manager and get the fix in, and that's it. And as I said, some of the fixes are ABI specific. And I think at the end of the day, and as someone that used to be in the Debian project for a while, I gotta say that package maintainers are the unsung heroes of the C++ ecosystem. Just look at how much effort Debian has to put to make C and C++ work. And I have a very funny illustration. Well, it's not really funny, but it's kind of funny. Which is Steve Langesek talking about a binary transition of a library in Debian. And he starts the email with, "Hello, cruel world." And then he goes about saying that we need to figure out better ways to manage like ABI changes across an ecosystem. It is not in scope for ISO, and a lot of people do not understand that. I know that we didn't, because this is the video evidence of us finding that out in the CppCon 21 fireside chat when it finally dropped. Oh, ISO cannot actually drive that, because it is literally out of the scope of the charter of WG21. Like, it's just not in scope. WG21 cannot solve this problem by itself. And no single vendor or maintainer can do it, right? It has to be a consensus building exercise across the entire C++ ecosystem. Finally, our expectations are, go ahead.
What's the point of SG15 if you can't solve this problem?
So the question is, what is the point of SG15 if we can't solve that problem? We can rally implementers around and try to build enough of a community of implementers to raise the overall quality of implementation by driving more interoperability.
So PL22, which is where WG21 is nested, that is about programming languages. So it's not outside the scope for WG21. It's outside of the scope of the IS, the international standard.
Right.
So it is possible to make adjunct standards that talk about this stuff. Just it wouldn't go in the C++ standard as we know it now.
Right.
Just to clarify.
So a clarification is that it would be outside of WG21, but it could eventually be a part of a larger organization within ISO.
No, WG21 can do it. They just can't do it in the international standard for C++. The one PDF that we all use right now, that can't talk about build systems. That's not what that's about. But you could have another standard from WG21 that talks about build.
Okay. So the clarification is that we can't put it into C++ standard, but we could create a new standard.
Yeah.
All right. Michael?
Yeah, I think there's a lot of confusion around what W21's charter actually is and what we can do. And I do think that this stuff is in scope for the committee.
All right, so Michael says that there is a lot of confusion and he thinks that we could do this in the scope of WG21. That's good news.
I think we'll get to this later, but we also feel like, move up. Yeah, we'll get to this later, but we also feel like the development of these like standards and the tools that support them and implement them probably needs to happen in between the big meetings, right? And then the big meetings will just be all us coming together and saying, did we build the thing we said we were going to build? Sounds great. Let's ratify it. Let's publish a document, right?
Definitely agree.
All right, we have agreement from SG15's chair. That sounds great. All right.
All right, so our expectations are too low. We're more comfortable than we should be with not using package managers, or even build systems in some case. I don't know what to say beyond that. It's just, it should be like a minimum bar for a project to say, I am packaged this way, I can be built this way. But we just accepted that this is the state of C++, and we just hope that our users will figure it out. For instance, would you be comfortable using a Python package if it was just a random GitHub repo that was not in PyPI? Probably not. And finally, header-only libraries are, and I'm going to use some more strongly worded language because I honestly believe that they are a cop-out, right? It doesn't scale, right? If you have two projects using the same header-only library, how can you make coherency between them, right? It doesn't work in all cases anyway. Even libraries that are strongly in the direction of wanting to do header-only libraries, at the end of the day, there are things that cannot be reasonably expressed in a header-only library. I'll get to you in a second.
That's a very quick question. What does cop-out mean? I think it's an American term. I'm not familiar with it.
Oh, what does cop-out mean? How do I explain it? It's kind of like when you give up and you just do like the bare minimum.
Okay, yeah, that makes sense.
Yeah. So to think about how header-only libraries don't scale, let's make a thought experiment. What would a header-only HTTP server library look like? An HTTP server needs a parsing library, it needs a logging library, it needs an encoding library, it needs thread and work management. Are we really just put everything into a single translation unit?
So,
I had a comment
yeah.
on a single translation unit
Okay.
that has major security implications if, like, you're relying on updating dynamically linked dependencies in order to push up security fixes.
Right, so there was a comment saying header-only libraries are also bad at accommodating security fixes because you might need to change a dynamically linked dependency in the production environment, and we would agree with that. In the back? Yeah.
I also have a comment about header-only libraries. So
Right.
if you have a diamond dependency and then on top it's a header-only library, and the in-between dependencies are using different versions, that's
Right.
basically a production crash
Right.
finding out very, very late.
Right, and there's the comment is with diamond dependencies and header-only libraries, you're especially susceptible because everything's built entirely from whole cloth every time you have a transitive but not exclusive dependency. And I think we'll get into that a little bit later, talking about vendoring and stuff too. Yeah, we agree with that too. So what is packaging, right? Maybe that's the big question. And that's kind of what we're saying is like, we need to kind of define what packaging is. To evolve, to make progress on this, we're going to have to figure out what packaging is as a community. What exactly do we mean? And I don't mean we necessarily need to be, philosophical about it. We don't necessarily need to be especially precise about it, but we need a working definition of what packaging is, right? It's not clearly defined. One of the big problems is the overlap. Because people are coming up with their local solutions, like Daniel was talking about, they're just making things work. They put the fix, the most ergonomic place to put the fix for them. We end up with version control, build systems, package managers, all doing some of the same jobs. All of them, like a source version, like they're all managing dependencies basically, right? When you vendor something into your source version control, you're pinning a specific set of version files for that build. When you, vendoring meaning take an entire source of an external project, put it into your project and pretend, like build it as with the same build system in the same context, right? Build systems, similarly, often fetch dependency source at build time, and similarly incorporated into the build process. Package managers, and that's what package managers basically do, is give you dependencies that fit your needs and that as specified, right? Similar parallels exist for, as we mentioned, you need the flags to all agree when you do pull all those dependencies in. All three of these different layers are trying to help you define how you get a correct build as far as binary compatibility goes, and it's spread through all those parts. And there was a question earlier about that. And that's exactly the problem, is that it is spread throughout. You can have things hard-coded in source control. You can have things hard-coded in your build system. You can have things hard-coded in your package managing ecosystem. Your dependencies can have things hard-coded, and all these hard-coded things, it's all over the place. And again, we wouldn't accept that kind of designer architecture in our C++ project, would we? We would say that's a mess. Let's refactor. Let's get that thought into one place so we can explain it and maintain it properly. But we're okay with it when it comes to our build system flags, which are really hard, really critical to a well-functioning system, right? So point is, like, you are doing package management. Every single one of you is doing package management, whether you know it or not, right? What we're calling package management. You're managing your dependencies. You're finding source versions that target that support the particular architectures you're trying to target. You're finding compatibilities between those different source versions. One way or another, you're figuring out how to get this version of that library and a compatible version of a third library all working together. You're resolving those transitive dependencies so that you can actually build at the end of the day. You're doing things to make sure you're binary coherent when you build all those things together, right? Like your include flags, your link libraries, those things. You're doing all these things. What about monorepos? That's something that comes up. I don't care about package management. I got a monorrepo. It's all solved, Bret. Fine. Do a monorepo. I'm not arguing against monorepos in this talk. We can talk about that outside. But you're still managing your dependencies, and you're still in the same community, right? You're still consuming, notionally at least, the same projects that everyone else is consuming. So it's in your best interest that the ability to share code is something that scales to everyone else's use case. Unless you're willing to fork everything into your monorepo during the vendoring process, and now it's your project. It's not an open source project. You just have an internal fork of an open source project, right? We have a question.
I just wanted to say this is what Google does.
And there's a comment about that's what Google does.
We have this we have a bunch of third-party libraries that we clone into our monorepo,
right.
And then nobody owns.
Right, and so Google has challenges in this space too. So I believe that there is a good workflow for monorepos. And I think if we had a better workflow for package management, there'll be the metadata itself will help that process too. We're not going to get into a lot of detail in this talk, but if we had a better definition of what a library was, how libraries are divided, how the metadata is communicated, like you could start seeing tools that are more shared across monorepo ecosystems for doing the vendoring process, updating the vendoring, that sort of thing, right? So again, it's still package management, it's still dependency management. It's just a different flavor where you're leaning on the source control system a little bit more than you are something fetching, tarballs from somewhere, right? So build systems and package managers, how do they work? There's a lot of variety here, but I think, as Daniel pointed out, we kind of need to handle that variety. So whatever we come up with as far as a packaging ecosystem, it needs to support multiple build systems. So we don't think we're going to be able to come up with, SG50 is going to come up with the build system for C++. We're just really skeptical about that. And for no other reason than there's still Node and Conda and pip and Cargo and you name your other favorite build systems, and they're going to want to build against these C++ projects, right? It's worth noting that each combination of build system and packaging or monorepo system, they interoperate differently. The people are just solving their local problems, and so the specific way you can get that build system and that dependency and that package manager all working together is very specific. We need to converge so we can, again, not reproduce that work the hard way every single time an organization needs to pull in something.
All right, so we talked about a lot of things, and I think there is an infinite backlog there. So we run the risk of saying, excuse me, let's solve all the problems and then just get paralyzed because we don't know where to start. So we think that there is a starting point, and our starting point is defined by what we don't expect. as we said before, we don't expect a single standard build system. Different build systems today serve different needs, solve different problems, and that's okay. We do not need to tell everyone uses CMake now, although Bill probably would like. And there needs to be room for innovation, right? Maybe the actual final build system for C++ is still not written, right? And so we need to give space for other build systems to still show up and experiment and eventually get adoption and have that healthy competition with the rest of the ecosystem. We also don't expect a single package manager, right? Debian users are fine. They are just apt-get installing libboost-dev and compiling against the system boost, and it works. For a lot of people, that works. For us, we need our own distribution, but at least they have a solution. And even in outside of the native package managers, the adoption is very fairly split, right? Between Conda and VC Package and Conan. There's no clear winner at this point, and I don't think we should try to declare one. The final point is a bit more of reflection that this space can be very complicated, and there's two axes today. There's the single language, multiple platform package managers, like the Python, Cargo, etc. And then there's the single platform, multiple languages infrastructure, like Debian, Red Hat. And so if you include this into the entire picture, I think it's clear that it wouldn't be reasonable to expect everyone to converge into a single package manager. We also don't expect a centralized repository. There's a lot of healthy ecosystems. There's no reason why we need to dismantle them. They're fine. And there's opportunities for vendors to start providing sets of libraries as a service, right? If you're a small C++ shop, it would be amazing if you could just say, here's this vendor, I'm just going to consume the libraries from this vendor, problem solved. We also don't expect a C++ specific package manager because, again, C++ needs to interoperate with C and other languages. And other languages need to be able to consume C and C++ better. This is the burden of being a systems language. It was the entire reflection on David's talk about how Rust can avoid some problems by not trying to do that kind of thing yet. So what is a reasonable goal?
I have a question. Can you go back to the centralized package repository part? So when saying this, obviously, Pipey will be a centralized package repository. However, when you mention there might be some packages for different vendors, strictly speaking, Kona is also a centralized package repository. However, it solves this problem by providing channels. Different vendors have their own channels, like Intel.
Right, so the comment is that PyPI is a central repository, but Conan has a more flexible approach where you have channels. And I'm...
Conan actually has more than one repository.
Right, but the important point is that we're not trying to advocate for a specific solution, right? We're saying that this space needs to be open because Conan didn't exist a long time ago. And maybe a better solution doesn't exist yet. And I don't think we are in a position where we can just say, everyone will use the Conan repository or for this problem, right? That's the point that we're trying to make. So we said a bunch of things that we can't or that we don't think would be productive trying to pursue. So what is it that we can try? And I think the answer is interoperability. Essentially, we shouldn't have to care about what is the build system used by our dependencies. If I'm using build 2, it shouldn't matter if the library I'm consuming is built with CMake. Today, that is not really the case. There is very little interoperability, and people need to do all sorts of adaptations between one build system to the other. There's a lot of custom code that gets written. I'm more familiar with CMake, so you can see the amount of fine modules that CMake has for all the different libraries that are built by other people, and how people create custom fine module in CMake all the time. And on the other side, package managers should have an easier time with C++ projects. I maintain a ton of packages inside Bloomberg, and I gotta say, it's not fun, because every single project builds in a different way, and you need to like be munging flags and throwing rocks, and eventually it lands. But it should be easier than that. And conversely, C++ build systems should have an easier time dealing with different package managers, right? If CMake has a dependency that was installed via VC package and a dependency that was installed via Conda, we shouldn't require CMake to have a ton of custom if statements all over the place to deal with all the divergence between all the package managers. And also, build requirements need to be expressed more portally. Instead of just saying -i, maybe you should say, here's the include directories you need. Here's the include directories that you should treat as system include directories, that kind of thing.
So what does that look like? Where do we start? I think, to start with, let's think about what is a library? So we're talking about packaging, but it seems like we need to start with library. Why, like, can I understand, it's like, how do you understand a package without understanding what a library is, basically? Can I understand a C++ package by just looking, like, usually there's some sort of archive, zip file, tarball, something like that. Can I open that up and just look at it? Can I see what's in it? Can I see what libraries are in it? Can I build, do I know how to build against those libraries, et cetera, right? Transitive dependencies are especially important. And importantly, I'll hammer on this again, do I get good, helpful error messages when I misunderstand what I'm trying to do with this package? How do we actually do, what do we mean by libraries? By the way, library is not in the ISO standard, so that'd be one of those things that would go in a separate standard if we pursued that path, right? What do we do now? Like, any combination of these things is a library, could be a library, right? Header files, source files, static archives, dynamic archives, the new module type files, right? Linker arguments, compilation rules. Header only is just header files. You could actually have a library that's just the archive with no headers. It's just providing symbols. We actually, in Bloomberg, sometimes we have meta libraries that are not actual libraries. They're just names that refer to other dependencies and other libraries. And we use that for refactoring and migration purposes and that sort of thing. So you might even have a library that isn't actually a library. It's just some metadata about a notional library. So these are all things that problems we need to support. So how do we define what a library is in that space? Who wants to write that document? Like, here's all the use cases. Okay, that's probably not going to work. So we probably need, instead, think about back to the maps and the globes that Daniel was talking about in an earlier slide. We need that coordinate system, right? We need to be able to say, there's a big space, but here's how you're going to orient yourself. And that looks like metadata. So that is data about the package and its contents. So we need metadata files that declare what libraries come in the package, declare what that involves, are there header files, are there modules, that sort of thing. And importantly, how to actually consume those things. It's worth noting that if we start doing this the right way, this is where the good error messages come from. Like you could start even having tools that analyze your package ecosystem to detect inconsistencies and incompatibilities at that layer, instead of, because there's some problems we just can't clang tidy our way out of, right? We need to have something with a higher view of things, and it could point out that, hey, you're using incompatible C++ versions in these packages as such, and that's the bug report, and not have to figure it out the hard way, right? We think we should focus on pre-built libraries first. We're not saying we shouldn't focus on anything else, but we think the pain points are especially acute here, and a lot of other things will more naturally flow out of that once we start understanding it better. Header only, interestingly, would be in scope because the requirements are a strict subset of a pre-compiled library, right? The big problem with anything that builds from source, although we would like to support that at some point, the big problem with that is that you would require quite a bit more complexity but in describing how builds work, the workflows, that sort of thing. And we think that's going to be more of a thing we should get to later. I know not everyone does. Well, let me back up. A lot of you do pre-built libraries. You just don't think you do. Anytime you have a library coming out of one build system and going into another build system, that counts for what we're talking about, right? So like we build from source, right? Like when we make our changes, we build from source, but it goes into a package that is consumed by another package in a different build system. So we build from source and we build from binaries in a way, right? Almost everybody does this in some way. If nothing else, they're using system installed toolchain libraries or something. Maybe we have a question.
Nested projects that don't propagate flags perfectly also count.
Nested projects that don't propagate flags perfectly also count. That's a good point. So if you're doing from source builds, but you're not modeling C++ as such in your build system, and there's some kind of like throw flags to the higher level guy and let him figure it out, that also counts as like pre-built libraries. So basically, if you're using include directories and -l flags instead of just letting your build system figure it out, that's where things start getting interesting. We should focus on coherent distributions first. By coherent distributions, we mean a set of dependencies that is assumed to be correct. It would be a snapshot of a distribution, and the distribution would be a series of those snapshots. Is that clear to everybody? That's not something everyone talks about. And there's not a great language around this, so possibly when we actually standardize something, we'll come up with better nouns, right? But this is kind of the language in the Debian land for this sort of thing. So we think we should assume that. There is interesting research into what's called dependency solving, right? Which is using tools to automate either partially or entirely the process of getting those snapshots figured out. Like, could you look at metadata for all the projects you're going to build against to come up with the set of the versions you really want, the newest set, automatically? Right now, it's generally more of a curation process. It's interesting research. Again, that's going to be a lot of work. So let's focus on like what seems to work now, which is you have stuff already installed on your machine, in your environment, your container, whatever. Let's work with that, right? This is not a new idea. Package config and the POSIX ecosystem is really popular and basically has the same assumption. I'm going to walk around your file system, the things that are on the file system, and then I'm going to help you build against those. It doesn't try to go to github.com and find given the parameters of the version ranges you want, the package you want, it just says, well, let's see what's here, right? This is a curl command against a URL that we didn't fill in all the way because it's not that interesting in this talk, but we can help you find that later if you're interested, showing that there are over 4,000 metadata files in the Debian ecosystem that describe the kind of metadata we want to start seeing, right? So it's not a new idea. It's actually very well adopted in some circles. And we think we can grow it, make it more portable, make it more standard, that sort of thing. And it's a common build workflow to consume this. Right now, there's some limitations to it. But you basically, you could use this kind of thing from it. You could use package config from a makefile to create a partial build command, partial link command, and enhance, fill in some blanks in your build system. Right. So let's talk about package config. We like it where it's going. We don't think it's where we're going to need to end up, is the short version of it. For instance, it works on Windows, but it hasn't really got that same level of popularity. So that's a problem. That's a big problem. It's extensible. You could add variables to a given package config metadata file, like new ones you just made up. Like, do you like ice cream? Yes, you could put that in a package config file. But at scale, it doesn't scale. Like, how do you search all the packages in your ecosystem that like ice cream? Package config isn't super great at that. So these are features that build systems and all of us will need at some point. For instance, this is why I'm not sold that we can just use package config to get module support to work, because we need some metadata in the package about modules that isn't in the package config right now, and how do we put it in there, and it's complicated, right? Also, there's a limitation of package config. Daniel referenced earlier, we needed to use actual semantic descriptions of what we need and not just flags, and that's because that's what package config does. It's really a flag munger, a partial compile command construction tool. It's not actually a metadata system as such. So if you want to get the metadata, you get metadata out of these flags that are described in these files by looking, oh, I see a -i flag. That's an include directory. I'll put this into my build system as an include directory, right? That's awkward. It doesn't scale. makes it harder to consume. We want all the build systems to have a relatively easy time with this, right? And certain kinds of concepts are not modeled at all. Actually, they're important concepts. Instead, they end up being, you figure it out. You put funky flags in your package config metadata files, and hopefully it works out. And the special pain points are around system requirements, like especially what languages you might need to link against, like the C++ standard library, or the Fortran standard library, or the C standard library, or the language that has not yet been invented standard library. Those are not things that package config knows about. You wouldn't put a -L, standard C++ in there, because that's not how you express it usually. And you wouldn't, but you would need to express that I need that and not the other standard library, depending on what you're doing. These are things that aren't expressed well. It also doesn't help you out much with dynamic linking problems. Sometimes when you link against even a static library, it pulls in a transitive dynamic library, and you need to have your search path at runtime altered according to where your production system is going to install things. Big problems, they're not really solved. Again, these are all just hacked up in build systems usually. Or build systems and maybe the packaging layer or some combination, right? So we like to iterate on package config. We like the general approach. We would like to get something a little more structured, a little more semantic, a little more scalable, a little more extensible. But this isn't a new idea. Actually, Matthew Wilkie actually proposed this already to SG15, and here's the paper number. It's paper 1313, which was an auspicious number. It did not get traction, so we would like to revisit that, right?
All right, so how do we replace this local maximum? Moving past package config is hard, because at the same time, it has an incredibly wide adoption in the Unix ecosystem, particularly the Linux ecosystems. But we know that it's not sufficient, right? It's really hard to succeed if we just come along and say, here's this new metadata, everyone stop using package config, let's use this new metadata that's awesome. But at the same time, we know that we can't really do modules well if we don't go beyond what package config does today. And so just for extreme drama, it's just hard. So how can we move forward? We do need a metadata format that is more extensible than package config, and it's more complete than package config. But we can't just do that in the abstract. So here's the pitch. The pitch is we need to accept that we must interoperate with package config. An ecosystem that uses package config widely should be able to continue using package config and use the new metadata format at the same time. That means generating PC files alongside the new metadata format, and that means generate like a minimally functional metadata in the new format where that new format doesn't exist from the package config file. It also means that we need to share the vocabulary of what the libraries are. And this is a really big point. It's not hard to comprehend, but it's profoundly impactful, which is if we already have Key25 GUI as a commonly referenced name in the package config ecosystem, this new metadata should just use the same name, because then dependencies can be declared across things that are in the new metadata and things that are just in package config. So if Key25 GUI is in package config, it should be in the new metadata too. So let's just start with CPS, right? The common package specification. We debated whether or not we should include examples of how and start explaining how CPS works. But honestly, it doesn't matter, because we know that there is a path to adopting CPS, and we know that we're going to have to refine that format. So the important point is we just need to get SG15 to work on this format, find out what are the requirements that are missing, get all the package implementers, get all the build system implementers together to figure out what is it that we're missing before we can use this new format. And let's include the interoperability with package config as part of that specification. What does it impact to build systems? The first one is build systems need to support package config. But supporting package config may mean something different than people would expect. So we shouldn't just invoke the package config tool and munge the flags into our build systems. We need to internalize the metadata that is in the package config files into first-class abstractions into our build system. We have, at Bloomberg, implemented this in like 10, 15,000 plus libraries. And the only reason we have succeeded in our migration to CMake has been because we were able to reuse this metadata, because it allowed us to gradually migrate build systems. Because the other build systems were producing package config, CMake could internalize package config, and everything worked. It should also generate package config and install package config, because again, interoperability with package config is key for this to succeed. We don't want to break package config users because there's going to be some edges pointing to missing nodes in the package config metadata because we're only shipping metadata in the new format. We should also support CPS, which is this new metadata format. And likewise, we should internalize that metadata as first-class abstractions in the build system, and we should generate those files on the way out. We should prefer CPS, but gracefully degrade to package config. And this is maybe a bit more controversial, but Bill agreed with us when we talked about it. Bill is from Kitware. And we should steer users away from build system specific metadata. CMake export files are great, but it would be greater if we had an interoperable format. Question?
So since you mentioned that the build system should consume this and create their own internal objects, right? Buildable objects.
Sorry, not buildable objects. You should internalize the metadata.
Internalize the metadata, create like targets or whatever that fits the build system best. However, in that case, if we expand it, if we come to build system side, there are some kinds of packages that is not only for building C++. For example, prototype. If you import a prototype CMake config, it gives you CMake functions to do work. And is that a part of build system specific metadata?
Right, so I'm going to try to simplify the question. So the question was that if we're internalizing CPS into the build system, but then we have packages that don't have libraries, C++ libraries sometimes, they have reusable pieces for our build system, right? They have a CMake file that we can use that provides functions for our CMake code. And yes, I don't think we're going to solve all the different spaces, but my hypothesis is that if we solve how to consume libraries first, we're going to have made a huge step forward, and then we can talk about that and come to SG15 to talk about how do we talk about build system specific modules in the package metadata.
Yeah, it'll also allow us, if we have that metadata, you wouldn't have to hard code that metadata in that CMake procedural code. You could just have it delegate the importing process to the CPS process, and then just enhance with extra code generation or whatever else you need to do. Does that make sense? So it's not one or the other. You can mix the two approaches in some cases.
Yeah. Let's get the other question, and then if we have time, we come back because we still have a few things to go through.
Yes, so, I was just wondering where this, it seems to me from what you're saying that you're giving a lot of importance to package config, and I'm not really seeing how that is justified. To me, package config seems to be a solution that is very important to one ecosystem, in this case the Linux ecosystem. But for example, on the Windows ecosystem, I don't see that importance at all. So I'm wondering, how is that justified? You say
right.
this is really the common denominator that we absolutely.
So the question was, why are we giving such importance to package config when package config is only really adopted in like the POSIX environment? And I think that's a fair statement. And come to SG15 to tell us which Windows metadata we should interoperate with. We'll have like naming concerns to deal with, but I'm not saying that we should exclusively interoperate with package config, but if we don't interoperate with package config on the POSIX environments, I don't think we can succeed.
So it could be just filling in gaps in metadata.
Yeah, it could be filling gaps in metadata.
Yeah, just a statement. It's more of a strategy of adoption, right? So package config widely used. If you could sort of slowly, insidiously replace it with CPS files, and then package config became better, and then once those files start getting produced by everybody, then they can be consumed by build systems.
Yeah, so the comment is that this is more of a strategy on how we can move the adoption on this problem rather than the technical decisions that package config is the king kind of thing. All right, let me try to move forward a little bit because I think we may run out of time. Yeah. So what is the impact to package managers? I feel bad because I already said that package maintainers are like the unsung heroes, and I'm giving more tasks to them. So they should provide the metadata when the authors didn't. And I'm sorry, there is no way around it. We need to move the ecosystem forward. We need the heroes to continue being heroes. It should be easier for them, hopefully. They should send patches upstream for the library authors to start producing those metadata files themselves, if possible. And we should have a well-defined mechanism for the package manager to communicate to the build systems what are the standard locations for those files in the system. On a POSIX system, CPS actually advertises specific set of paths and specific mechanisms to override those paths. On Windows, that's probably not the common practice. So those are problems that we have to solve too.
All right. So how do we make it happen? How do we make it happen? Right? What can we do? We talked about specs and metadata, but what about us? What are we going to do? Right? Well, we think you should get involved in the tooling community. We think SG15 is a good focal point for that. We expect that we will have more interesting, more iterative, more open source style projects spinning out of there. But this is a good focal point for everybody to keep up to date on things, to hear the big proposals, to keep abreast of requests for comments, that sort of thing. This is all work. It's not going to happen by itself. A lot of people have been sitting back and expecting compiler vendors to implement modules on their own somehow without funding. A lot of people have been sitting back and expecting build systems to just support modules without funding. We're not going to get packaging that way, right? We're going to need people. Every organization needs to think, what's the impact to my organization? What are the risks? What are the upsides for my organization if we do this right? And start like making some economic decisions, some business decisions about this is in your best interest, right? It would be bad for your organization, open source, for-profit, not-for-profit, whatever, if the rest of the ecosystem went in a direction and you were stuck on your own, and again, you had to fork all the projects you use and maintain them yourselves for the rest of the time, right? That would be bad. Again, SG15 is more of an approval body. We expect things to kind of spin off as we go. We want you to work with your vendors and your maintainers. So talk to them. Let's make issues that we can focus on and upvote and kindly talk about how we would like certain things to happen. When your tickets, if it's for profit, issues are ideally contributions for more open source projects. When you're talking to open source projects and you feel like it's too much for you to get in there, hire some contractors. I don't expect you to spin up a packaging team in your organization necessarily, but let's get well specified tickets, and then we can say, well, someone could work on that. And let's kick into the kitty, and we can get that done, right? Otherwise, just in general, keep communicating to each other, to the outside ecosystem, to our neighbors in the coding community, that this is a problem that we care about, the problem we want to work on, the problem that we're prioritizing. People need to hear from the C++ community that this is something we're going to work on, right? And this is not just us preaching at you. Bloomberg is investing in this. Bloomberg and Kitware are partnering on this build metadata problem, especially focusing on module support. If you want to hear a lot more detail about that, check out Bill's talk when it's available later. Bill from Kitware is talking about how modules and CMake are going to work. Finding alternatives, as Daniel said, to CMake-specific metadata is in scope for this project. So if we can get a version of CPS settled down, we're willing to prototype this stuff, right? Let's see. This is.
Yeah. So we did a pitch of a short-term thing, but we wanted to give a bit more hopeful messaging at the same time, instead of saying like, the only thing we can do is a metadata file on disk. That's the limit of our abilities. So let's talk a bit about where can we go after this. The first one that Bret mentioned before, this is a super interesting problem. There's many PhDs to be had in figuring out algorithms for dependency solving in C++. Todd Gambling from the SPAC project gave a great presentation at CppCon 2021 on this topic. It's a super interesting field. We don't think that we're ready to tackle this like wider than a single ecosystem, but this is a very interesting future area for Convergence too. Package name registry. So even though we're saying that we don't think we can or should try to converge to a single repository right now, a registry is a much more interesting idea because it will be a lot easier if everyone agrees that Boost Beast is Boost Beast, and we don't have to keep using different names in different ecosystems because this package manager decided to just create a new cutesy name for the Boost Beast project. So a name registry is an interesting, not so hard idea. There's several examples of organizations that maintain lists of names and who owns those names. For instance, Lanana has a registry of every directory under /opt. On a Linux system, you're supposed to go and register and say, like, we have /opt/bb registered, and so no other vendor should be shipping things in that directory. Yeah, or USB vendors, like registry of USB devices and vendors and device categories.
Just a quick comment, if you look at the Linux standards base ISO standard, which is also published under SC22, a large part of that is actually just a list of such names.
Right, so the comment is that the Linux standard base, a large part of the specification is just the registry mechanism for a bunch of different names. Standard distribution formats. While I don't expect us to everyone use a CppPar format, it should be trivial to convert from a deb file to a Conan package to a VC package. If we have the metadata, we have the files in, it should be easy to do.
Is ABI changing flag information, names or anything encapsulated in any of these formats that you're talking about?
So the question is ABI important and platform important flags documented in the CPS format? I'm sorry?
And also package options.
And also package options. So remember when we said what we want to focus first? So for now, we're going to focus on a coherent system that is already installed in the system. We think that there is a space for dependency solvers that are aware of those ABI requirements. And that's an interesting future thing. But for now, our focus is that we think we should just land the coherent system environment first.
Maybe your question is more like this. If you took an RPM and you turned it into a deb file and you tried to install it in a Debian ecosystem, you would get a package you would not actually want to build against. But mechanically, it should be easy to do that, is what we're saying. Yeah. And ideally, you would have tools, as I mentioned earlier, that would point out, oh, you can't do that because these flags don't match, or this doesn't have a 32-bit on this ecosystem, or whatever. Does that answer your question?
Yeah.
Okay.
Yeah, I misunderstood the question. Yeah. Even though I don't think we should or could converge into a single package repository, there is an opportunity for us to have a single repository protocol. Like, how awesome would it be if I, as a small C++ shop, can hire a vendor or be a part of an open source ecosystem and be working with that vendor with a long-term support for sets of libraries that are coherent. And then at some point, I want to switch vendors, and I can just switch vendors without having to redo all my tooling. Yeah, my IDE would just say like, oh, the repository is now in this other place, and everything keeps working. I don't have to rewrite everything in my tooling. That to me is probably one of the most impactful outcomes if we get that in the long run, because I would love to see an ecosystem of vendors providing long-term support for here's a bunch of libraries that are built coherently together for this set of architectures with this set of settings. And you as a small C++ shop can just hire us and we'll provide you with the download URL for you to get it. Someone had a hand?
I think to have multiple distribution formats works for internal networks. But if we want to share this on public network, this creates a problem. How do you assign those packages?
So the question is, multiple distribution formats work fine in a local environment, but in a public environment is a problem because how do you assign those packages? Well volunteered. That's a problem that is a problem that needs to be solved for us to get there, right? So I don't think I have an answer to that, and I shouldn't, because that's for the future. And I hope I see you in SG15 trying to sort that out. And finally, testing. We have had, at Bloomberg, we have this fully coherent, aggressive dependency rebuild package orchestration framework. And it's common for individual projects to run C-test as part of their build. And in many cases, the unit tests of package A didn't catch the bug. The unit tests of package B that used package A didn't catch the bug. But then the unit test of package C that consumed package B, that consumed package A, identified a bug. And because we have an all or nothing repository, the change was rejected. The owner of the library A got a report saying, here's how the test failed, go reproduce that yourself and fix the bug. So it would be awesome if we had a mechanism for me, as I'm building a library with many dependencies, as I curated the version of all the dependencies of that library, if it was easy for me to say, let's run the test of this library against the exact versions of the dependencies that I'm going to use. Conversely, if I am a library provider, I want to be able to say, oh, I have a bunch of libraries that depend on me. Can I just run the test of everyone against my new version? That would be amazing. I think the punchline is, I want to know it worked, like for real. And I think we have 13 minutes for questions. Thank you. Anyone?
Comments? All right, well, no one else is going to raise their hand. So, so the ecosystem right now with things like Clang, let's see if I can say this on video without getting any particular company in trouble. But like the modules implementation there is going nowhere as far as I can see. And that's in part because the major corporate sponsors of Clang have no interest in really going down that path. So are we going to run into a basic problem here where we can't have the three major implementations even support the basics of modules before we even talk about the packaging?
Okay, so the question was, we have a problem of uneven implementation of modules, and part of the problem is related to how specific compilers are being funded and what are the priorities of companies driving the funding of those projects. And isn't that uneven implementation going to be a problem for module adoption? The answer is, of course, but I think, let me put it this way. C++ with headers barely worked, and I don't think anyone is happy. So even without modules, this problem is still incredibly important. It's just that with modules, the barely working solutions we have just completely break down. And I want to give Michael a chance.
I think that's fair.
Yeah.
So there are Clang people working on implementing modules, and I don't have any concerns that within the next year or two that Clang will have C++ 20 modules support.
The comment from Michael is that it is in the roadmap. It is happening. Timeline 1-2 years for C++ 20 modules on Clang.
And I'll say, like, this is actually a bigger problem than modules. Like Daniel was saying, he said in one aspect, but like, I think this problem does affect the large companies with large monorepos and their own custom built systems. It is in their best interest to make sure this works. Where it might be arguably in their best interest to keep using a legacy module system, it wouldn't be in their best interest to ignore this problem. So if anyone's in those organizations and they feel like they need some support in explaining well why that is true, again, jump into SG15 and we can help like do some research and or whatever, make some arguments and that sort of thing. This is something the community can help with. And more, again, one of the things nuts we want to crack with this is to make it more, egalitarian or more democratic or whatever word you want to use to get into this space. So there's a large untapped resource of smaller organizations that aren't, multi-billion-dollar market cap, companies that could pitch in, an intern or whatever. And it's just too much to expect an intern to jump in and implement modules in Clang. It's not too much to expect an intern to come and make build tool ship CPS or something like that. So I think there's more opportunities here to make targeted impacts. And I think we should, it's going to take some effort from the leadership in the C++ community to set those projects up for success and to support them. But I think this is going to be a different kind of problem. So I don't think they're quite apples and apples when we're talking about those two kinds of problems. Bill hasn't had a lot of comments, so I'm going to go with Bill.
All right. I think we can make sort of an analogy here. It was something that happened in CMake with Ninja. So we had this dynamic dependency thing for Fortran to do Fortran modules, and getting it. We basically had Ninja fork for like 5-6 years. C++ modules came around, and suddenly they cared about module support and dynamic dependencies. So we were able to get it in through that. And I think this has been a problem in C++ packaging libraries. I think modules is sort of the fire to light under people's butts to get them moving in the right direction and care about this problem. Everyone's got sort of a solution to this problem now. So we're living with a world of C++ where it's kind of hard to find a library and the right headers on this, even if it's on your system. It's hard to find it and use it. But we're living with it. But I think modules will make it way harder, and they are coming. They'll be here in 2-3 years. It's going to be here. So let's get the ecosystem ready for them by fixing a problem that's been around for a while.
Yeah, I guess as far as modules are concerned, as soon as I can actually make boost in modules, then I'll believe it. Don't get me wrong. I want to see it as soon as is humanly possible, but until we can take major libraries like Boost and modularize them into pieces, I think we're going to have a problem. And I would also put in my 2 cents for saying, let's figure out how to work with the Boost community to use Boost as the prototype for this, because it is a massive thing, and a lot of people complain about whatever, and being able to split it up, have it packaged well, it's a challenge, but if we can do it there, then we can do it anywhere.
I'm not sure I could summarize all that. I think Bill had an interesting point about Ninja forking, and actually success is a very good argument for getting other people to fall in on, even when they're reluctant, right? with respect to like Ninja supporting certain kinds of dynamic dependency scanning. And Jeff had some concerns about module support, but he is interested in seeing Boost taking the lead in some of the modularizing popular libraries as like an incubator kind of project, and I think that makes sense, yeah. I think there's some interesting hallway discussions about how exactly we might do that, so let's have some of those too.
Yeah. So one of the problems that we have in this space today is because the different platforms are so diverse, that it's really easy to write a build script, write a packaging that like works perfectly fine on my platform, but without me realizing it does not work at all on another platform. So an interesting like trade-off that we will have to make here now for this package format is we either specify the package format in a way that it works on all the platforms, but that will require libraries probably to adapt their existing builds so that they can provide metadata that they're probably not generating today.
Right.
Or have it the other way, make it easy to adapt for libraries, but then risk that on some platforms this metadata packages might not be consumable. So what is your opinion there? Like what would be a reasonable trade-off here?
Right, so the comment question was, there's some trade-offs between making it easy to adopt and being correct and portable. Is that fair? And how do we, yeah. Honestly, the packaging ecosystem is kind of messy already. And so we expect a variety of approaches to solve it. Daniel kind of hinted at sometimes we're going to need package managers to clean up the messes of certain libraries. Our experience in adopting these kinds of metadata has been that we're going to need, the build systems are just going to need little escape hatches from time to time for your dependency has the bad metadata, let me just fix it for now until they merge my pull request or whatever that looks like. And CMake, upstream does that all the time, like where they have fine modules that fix things that are actually not really packaged at all, right? So I'm not so pessimistic about that, I guess, but those are interesting concerns, and we should expect more. Our punchline, I think we expect if we set the requirements and we expect them to be met, we expect people to figure it out. It might not be, mathematically pure, the solution, but it'll be something that'll work.
And figuring out the requirements of those platforms that we don't usually see because we're mostly focused on I think I can say 100% focus on POSIX environments. So that's why we need to use SG15 as this focal point. So people that have this more curious requirements can actually present the requirement. And it may be the case that we will have to say, for now, hold on, we can't, our first version cannot satisfy that requirement. We're going to have to put that in the future work category and create a roadmap for following versions of that standard to extend its scope.
One more thing, though. We are shipping that metadata. So VC package contains config packages for C++ dependencies. Well, someone needs to go in his VC package and ship CPS also. Maybe we don't care about package config, but get CPS in there. And then those config modules could use that CPS data instead of having it hard coded. There's a roadmap there, and it's not crazy, right? Yeah. Okay, Peter?
I really liked where you were going with the focus.
Right.
To what extent is this coherent distributions approach compatible with, say, a sandboxed coherent distribution on a system that is incompatible with, say, the operating system, your operating system's coherent distribution?
Can I respond? Yeah, sure.
So the question was, we're talking about coherent systems and how extensible it is to environments where you actually have a divergent ecosystem inside a single environment, right? And the cross-compiling is a great example of that. And maybe telling a bit how Bloomberg does this will help explain. So what Bloomberg does is we have the baseline Red Hat system that we put in a minimalistic container with only the application compatibility guidelines, level 1 libraries. And then we build everything from scratch and we deploy to /opt/bb. So we actually have two systems in the same environment. You have the Red Hat system that we tell our developers not to touch. And you have the Bloomberg system in /opt/bb, which is where our CMake toolchain points to, where everything points to, right? So when we say coherent distributions, it doesn't mean that we have to Linux from scratch the whole thing. We can create like pockets of compatibility in specific situations. Does that answer your question?
I think I would like details, but overall, yes.
Okay.
You had your hand up earlier.
Yeah, I sort of worry about excluding the build system specific metadata, whether that will, how to say, discourage innovations in the build systems. Because those are where the economics.
Sorry, I don't think I understood. Excluding what?
Innovations in the build systems.
No, you.
He's saying he thinks there's still a role for CMake modules and stuff like that.
Oh,
Repeat the question.
so do you want to repeat? I don't think.
Okay. So there's some skepticism that there's some concern that there will always need to be a place for build system specific helpers, even at like the library level. Does that summarize it, or?
I'll give 2 examples. So for basic package, for
Right.
example, 2 things that makes this very easy to use.
Right.
First, it is a multi-configuration package management.
Okay.
You install a package, you got release debug at the same time.
Right.
That works with CppNow very well.
Right.
The second part is that because it directly injects CppNow, like runnable CppNow functions through CppNow targets. So as soon as you import the targets, you get all the functionality, you don't need any scripts, any other tools. Everything can be done within the system. By consuming the metadata file you described, are these things still possible?
Yes. So 2 use cases are brought up. One, using multi-config packaging, where you might have debug and release modes deployed together of like a library. And then there's sometimes you have a library that's deployed with functionality, maybe a library that you have code generation sitting next to. So you generate some code, but you also link against some code. And that's part of that package. That's pretty popular for things like protobuf or things like that, right? I'm confident we can support both of those. I think in a lot of cases, people use this metadata and they'll build on top of it. And that'll simplify their implementation, so it's a win for them. Again, CMake itself, that ships fine modules out of the box, would likely just use the CPS data when it's there. We could probably just get that to work. VC package could generate the CPS data, and when it generates its fine modules or whatever, again, it could use that metadata. So maybe that module you're talking about that maybe had some instrumentation options or something like that would fundamentally rely on the CPS data, but then layer on a little bit of build system specific thing for the things we can't express with CPS. I don't expect CPS to ever tell you how to build something, build the entire project from source as needed. Maybe someday, if we get really good at like having the same project structure in all of our C++ projects, or all using the same build system, that might be in scope, but I'm skeptical that we'll get there anytime soon. So it seems more likely that we're going to be, there will definitely be a place for build system, what I call plugins or extensions at the build system level shipped by individual packages even. I think that's probably going to be a place for that for quite some time. Some build systems are more opinionated. It's just declarative metadata like config files, and you have to all use the same project structure. And there's probably a space for that. I mean, so like they would probably still need the CPS data, but there's downsides to that approach in that you have to force everyone into your framework so that of like your perspective, so that they can be part of that ecosystem. And again, our case is like, let's find the common denominator, and we'll enable a lot of things basically. I hope that was a good answer. We have.
We're actually out of time.
We're a little over. Actually, we're right at time because we started slightly late. But thanks for everyone for listening. Catch us in the hallway. There's lots to talk about here. Jump in the community and let's get some work done here, right?